Hello and welcome to the 18th webinar in 12D's Industry Solutions webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator here at 12D Solutions. Our Industry Solutions webinars are designed to provide insights into overcoming challenges in an evolving industry in more effective and efficient ways. We'll continue to run these webinars regularly and record them for posting on our YouTube channel and website. Our first 17 webinars from this Industry Solutions series, as well as the first 14 webinars from our training series, are available online if you missed those. During this live presentation, you'll be able to type your questions along the way, and we'll answer as many as possible throughout the webinar. At the end, I'll also read out some of your questions to the presenter if there's time. Today's webinar, Rapid Design Changes in an Urban Environment, will be presented by Tim Brooks, who has been with 12D Solutions for over 3 years as the 12D Model and 12D Synergy Training Manager. Tim coordinates and writes 12D Model training manuals and writes the 12D Synergy training manuals. A civil designer with 17 years of experience around Australia and the UAE, Tim has worked on a variety of civil projects including motorways, highways, local roads, industrial and subdivision estates, car parks and rail projects. This webinar will explore using a number of 12D model design features in conjunction with each other to make changes to a design quickly and easily. These include an overview of Super Alignment Computators, named parts and positions, smart chainages and chains. Over to you, Tim.
Thanks, Lisa. Good afternoon, everyone. I'll just go over that again. Design changes are constant in today's working environment. Finding the most efficient way to deal with these is always a challenge. Ever wondered whether there's a tool or a different way you could be designing to make your designs more efficient or reactive to changes? In this webinar, we will look at using a number of 12D model design features in conjunction with each other to make changes to a design quick and easy. So what tools does this involve? We're going to have a look at super alignments with computators. We'll also have a look at a number of super alignment features, including name parts and more predominantly name positions. We'll look at using smart changes inside the MTF editor and then combining all these tools using a chain. So let's have an overview of these tools individually, and then I'll show you the benefits of using them in conjunction with each other. So inside my 12D model project here, I have a simple little urban intersection that is being upgraded. So the design is in progress. First of all, we're going to look at our super alignments. I'm not going to go into too much detail here. We do have a number of training videos on the 12D model website that you can go to and watch if you want more detail. But the main feature we're going to show here is using computators. Computators in super alignments is basically a way of linking another alignment or a super alignment to another super alignment. This means if you were to move or relocate one alignment, those other alignments would follow it. For example here, if we move this main line alignment, the curb return would follow it. So let's have a look at a few of these computators just briefly to show you what elements were used here. So I'm going to open up this curb return to start with and go into the part editor. And let's have a look at the horizontal. In here you can see I've used 3 computators. We know they're computators because they have the little asterisk on the end. The first and last computators here are basically used as construction computators. You'll see that the visible button is unticked. This basically is allowing me to tie in to the standard width. The middle computator here, it's a nice one called fixed compound, and it allows us to do many different types of curve returns. See the one that's used on this one's called basic turn. That allows for a set radius with an approach and departure taper. Other options under this one include just a normal fillet curve return. You've got the 2 and 3 centered curves, high entry turns, even cul-de-sacs, and 3 tangent curves. So plenty of options for you there to go and explore. The vertical is also computated on this one. It matches the grade of the 2 roads and then has a free compound in the middle. Just like the curve return computators, we can also computate things like traffic islands. So we'll go and have a look at this one here. It's a nice simple one. Again, in the horizontal, using 3 computators and using that fixed compound computator to create the fillets on that traffic island. Okay, so just using the fillet, set the radius, and you can see here that it is linked to this major super alignment with an offset. And again, the second one linked to the other major alignment with an offset. The same for the other 2 fillets, except it's linked to 1 alignment and 1 curve return. Okay. And they're just joined up with free lines and free arcs. The vertical on this traffic island is very interesting. I've been able to do it with 1 element or 1 computator. And this simply drapes onto a tin surface. So I've been able to create a tin surface with strings from the design around it and simply just overlay that traffic island onto that surface. Very easy, very quick to do. I'll just open up one more traffic island here. This one, it's a little bit more complex, or it uses a few other elements that may be of interest. Again, in the horizontal, using a fixed line computator to link those straight line components. But the other 2 elements I want to show you in here is one called a free compound. This allows me to do this taper. It sets the 2 radii and the taper length. So again, being able to do all 3 of those basically segments with 1 element. Another one here is this floating arc right at the tip of the island. It's using the from, end, and radius with a sweep. Basically, the sweep allows me to do that 180-degree end on the traffic island. Again, no differences with the vertical here. It is just computated onto a surface. So it takes care of the vertical in 1 hit. So that's using computators with super alignments. We're going to go and have a look at a few other features inside the super alignment now. So to do that, I'm going to open up the major super alignment here. It's a fairly simple one in terms of its horizontal geometry. It's just the 1 element or fixed line. Okay. Inside these elements, if you may have noticed, if you're using element design, that you have this name area. At the moment it's grayed out because it's not being used. It's totally optional, but this is what we call name parts. Now if you were to have an alignment with many different segments, you can name those individual elements or segments. The naming of these segments allows you to reference positions inside your MTF modifiers. So simply just give it a name. Just a word of caution here, if you do name them, make sure you don't come back and change the names once you've referenced them. You'll break your links. If in this case, like me, you don't choose to name the element, the entire alignment is given a generic name called string, in which case you can use that to reference in your MTF editor as well. So we'll finish that one. So that's name parts. Another referencing feature inside a super alignment is called name positions. This is found under the part editor box. You simply click and hold it to generate the flyout. Come right to the end and select name positions. You can see I've got one in here already. It's called intersection, and it's referenced by using a cut with another string. Basically, that gives me the center of this intersection. I can then use that in my MTF edits to either trim the strings or orientate those modifiers around that intersection. So again, if that's one of those strings moves, all those changes will be relative to that position. So let's have a look how this works. Let's come and insert a new one. You come over to the top right here and you give it a name. I'm going to call this one car park. Come down to where it says type. We'll have a look at the option arrow, and this is a list of ways that you can define the positions. You can define it from the start or end of your alignment string. You can define it by a fixed chainage value. That's the default one you can see there. You've seen the cut option. You can also reference a drop point. So this is a simple XY coordinate. You could use this in locations like low points in drains, where you have to independently grade table drains to a certain position. But that XY low point would never change. You can also reference a vertex on the alignment, or as we've seen before, you can reference a name part position as well. For this one, I could use a number of different options. I'll use the vertex one. You'll notice that straight away the chainage is now grayed out. You cannot use it. And you have to come down to where it says vertex. Simply enter the number of vertex here. Now I do want to use the start vertex, which is number 1, so I can leave it as 1. But I also have the option here to add an extension to it. So if I don't directly want to be on that vertex, but I want to be 20 meters up the road from it, I can enter a 20-meter extension. Make sure you hit set, and then we can finish the name position panel. I'm going to save and finish my Super Alignment editor. And now we can come and have a look at our MTF modifiers. So here are my strings. I'm going to open up the MTF editor for my major through road. And we're going to insert a little car park bay on the left-hand side of the road. So let's go and open the left-hand modifiers. I'll just expand this a little bit so you can see a bit more. I'll show you a few features in here that will allow your design to stay more dynamic. So faster with design updates. First thing I'm going to come and do is create an alias. For those that aren't using aliases or don't know what they are, they came in with version 11. You can find them under the interval alias. You'll also note that I've created these aliases at the top of my MTF editor. If I create them at the top here, that means I can reference these positions or modifier positions anywhere throughout the rest of the MTF editor. The way these work is you just give it a name. So again, I'm going to call it car park. And then we can select a start and end point covering the length of your modifier region. Let's have a look at the blue arrow options here. This opens up a list of what we call our smart chainages. All except for the top one there. A typed or a fixed chainage is not smart. That's the one you want to try and avoid. Okay? As we all know, when you change your design alignment, the first thing that changes is the chainages. And if you use that one, you have to come back into your MTF editor and update all the chainage values. So we're going to use these other ones. What's in here? Well, you can reference things like the start or end of your reference string. You can reference the start or end of another string, or even the highest or lowest drop chainage of another string. Those last four, they're really good for things like curve returns, where you have to trim strings out of things like intersections. Use the start and end of another string. If, for example, I was to come in and modify the radius value of this alignment, all I have to do then is recalc my design strings, and the curve and footpath strings here would automatically trim to the new end or start of those curve returns. Some other ones in here, we have the name part smart chainages. That's referencing those name parts that we just talked about. We also have the name positions on reference string or other strings. We're going to use the name position on reference string for this one, and then we come to the names panel and we can pick our car park from the list. We're going to use the same one for our end mode, so name position on reference string, and again pick the car park from the list. Go OK on that one, and that defines our chainage range for those modifiers. Just going to come and insert a couple of more blank lines in here, and on the next line I'm going to create a new region. Again, region is another new feature that came in with version 11. They are very great for organizing your MTF editors. They're like a heading. So again, I can put car park in it up here for the description. Go OK. You'll see it creates this header. But the great thing about a region is they are collapsible. So like these ones down below here, they contain all the modifiers concerned with that event. When you're finished, you can collapse it up. Makes your MTF editor nice, neat and tidy. Okay, so the first modifier I'm going to do here is simply insert another string. This string is going to replace our edge of carriageway. So I enter the string name. I'm going to use a line marking string, a continuity line, and I'll put an L on the end for left-hand side. Come and pick my color for that string. Now I'm going to use the viz colors here, just because then my viz polygons are automatically colored. The width, don't forget, if you want to check your widths or you can't remember them, you can use your measuring buttons here. So I'm going to use string to point, length, and I'm going to go measure between those two strings to find out what my width was. 0.7. I can remember the crossfall, -3%. And now I just have to select the position of where I want my string to go. In this case, I want it to go before that curved lip string. I'm going to use my middle mouse button here and go and pick the string instead of typing the name. So that makes it nice and easy for me. And then I can come down and pick my start and end modes. Again, I'm going to use my smart chainages here. This time, I can use my relative to alias options. We created the alias earlier, so I can use relative to alias start. Again now, I can go and pick that alias name from my list. And I've even got the option to add extensions here. So that car park alias, it might define the length of the car park bay, but maybe I need to include a little bit more for tapers. Likewise for the end mode, relative to alias end, select car park from the list, and again add a little bit more onto the end to allow for my tapers. Go OK there. Now in my MTF editor I have the auto recalc button ticked on, which means when I hit apply it's going to update my design strings for me. Oh, I've missed something in the alias. joys of doing live demos. I've selected the same position here, where on my end part I should have given it a length. So if I wanted to find that length as 20 meters, I can go OK, and now when I hit apply, that's automatically going to update for me. You'll notice that my continuity line has not displayed the Viz Road bitumen color or asphalt color that I selected. It is in fact displayed as a white continuity line. And this is because inside my function, I have applied a design map file. And that just remaps the string to a final color and or line type. After our string's been inserted, I now need to go and define the width of that car parking lane. So we're just going to use a simple modifier link modifier. Again, with my middle mouse button, go and pick the string I wish to edit. I do want to modify the width, but I am going to maintain the crossfall, and I am going to set a constant width. So I just need to enter that constant width value in. Again, with the smart changes, I can come and use that relative to alias start, pick the car park. I don't need an extension this time. End mode, same thing, relative to alias end, pick the car park from the list, go OK, hit apply for the recalc, and you can see our internal width is now set. That just leaves the start and end tapers to put in. So in here, I'm going to add just a normal comment, just to separate the tapers from the other modifiers. Now the tapers are just a modifier link modifier as well, so instead of inserting it again, I'm going to right click on the end number here, copy it, and then paste it down into my blank line. This way I don't have to fill out the whole panel again, I can just make the changes that are necessary. So in this case, we're no longer setting a constant width, we can come and have a look at our options. Now normally you would set a width to width for a taper, but now in version 11 we have these new smarter options. So I can go width to pos, or width to position. What this means is I can enter the start width, which will be 0, but 12D will automatically measure and look up that end value for me. Smart changes for this one, I can go on this first one, show you some different ones. We can use relative to self end on this one, and I can add the -5 meters in. And for the end mode, I could again use the relative to alias start, or I could have used this other one called relative to previous start. It asks for a number of rows back. I can go 1 row back. It does ignore the comment lines, so it'll get the start value from this other modifier. Again, just a word of caution with this one. You don't want to go using it where you're referencing 10 rows back and you have the potential to insert other modifiers in between them. Go OK there, hit apply for the recalc, and there's our start taper done. Now we can do the same for the end taper. I'm going to copy and paste that one down. Go and make the changes necessary. In this one, just going to swap it around this time. So instead of width to position, we're going to go position to width. Again, back to a 0 width. And our start mode and end mode, I'm going to use the relative to alias end. Select my car park again, and another new one for the end mode, we can use relative to self start. And again, I can just add my 5 meters on for the end of that taper. Go OK there, hit the apply for the recalc, and my end taper is done. So that's the modifiers for that car park. Now that's not a lot different to just choosing using a fixed chainage value. So why use the smart chainages? Well, it comes when you have to update these things. For example, if I wish to lengthen this car park bay, all I have to do is come back up to the alias and modify the extension. So let's double it. Let's make it 40 meters. Hit OK, and then hit apply for the recalc, and you'll see that that car park bay has doubled in length. I didn't have to come down and modify all these other modifiers to suit the new length. Okay, they automatically reference those positions. Another way of updating it is I may wish to change the start location for this car park, in which case I can come back into the alignment, we can edit our super alignment, and we can go and change that name position. So let's, instead of starting 20 meters up the road, let's only start at 10 meters up the road. Hit set, finish. We'll save and finish our super alignment editor. I'll come back to the design view so you can see the strings update. Hit the apply for the recalc, and there you go. The whole car park slid back that 10 meters. Again, I did not have to come in and change any of these modifiers to do with that car park. Very dynamic way of updating your design. Just to show you where else you can use these aliases, because it was used up the top here, as I said, I can use it anywhere else below that. So I've got another modifier in here turned off. It's an absolute modifier, and I'm going to use it for my start width of my footpath here. Now, what would normally take two modifiers to change this width to a constant line, because of the taper, I can do with this absolute modifier, because I can define a constant width from another string. Okay, so I'm going to turn it on. It is modifying from the start of reference, so that's the very start of our design, through to that alias start, which is the start of our car park, which is this position here. So let's go OK on that, hit apply for the recalc, and you can see that footpath width has now been modified. Nice and easy. Again, if I change the position or the alias, all those modifiers will follow suit. I don't need to come in and change the values. A lot of time saving to be made there. So let's exit our MTF editor. And now let's have a look at chains. So for those of you that don't know what chains are or haven't used them before, chains are the single most efficient tool that you can use in 12D. They are fantastic for repetitive tasks. They're found underneath the utilities menu, chains, and you've got your create, edits, etc. I've already created one here that we're going to go and have a look at. But chains can be used not only for design updates, but they could be used for plotting things like long sections and cross sections, updating volume reports, recalculating sightline checks, outputting plan information to other programs, all things that take quite some time to do. And again, as you know, you have to redo them every time your design changes. So some of those tasks could be 20 minutes long, they could be a couple of hours long. And so every time you modify your design, you're having to redo that. It's a lot of time over the life of a project. So what does a chain do? Well, this one's a design chain. It's probably one of the simplest chains you'll ever be able to make. It literally has 2 or 3 commands in it, mainly evolving around the resolve super alignments and the recalcing of your design strings. When you create a design chain, I do recommend that you create it whilst you do your design. If you try and come back at the end of your design and create your chain, you have to remember the order everything was created in, because the order is very important. For example, I cannot resolve a curve return alignment until these two major alignments are resolved. So it needs to come after that. So let's go and have a look how this would work. I'm just going to turn on some other models in this view. I'm going to turn on my major alignment model so you can see that. I'm also going to turn on my survey cadastral boundaries. Now it might be a little bit hard to see, but the cadastral boundary here runs inside the front of this footpath string. So I'm actually taking quite a bit of land out of this property. So in this case, I prefer to shift the road to the left and take the resumptions from the other side of the road and leave these properties alone. So the starting point, of course, is to come and modify our major alignment. So I'm going to come into the part editor here, come into my horizontal. You can see it's just the one line on this one. Very easy to update. I'm just going to shift it to the left 3 meters. So using -3, hit set, finish, and of course save and finish that Super Alignment editor. Again, just going to come back to the design view. You can see that alignment has shifted, but at the moment the design strings, the curve returns and their strings, the traffic islands and their strings, and all these string trims for the intersection are still in the old location. So to update those manually, you first of all have to come in and resolve all those alignments, and then you would have to recalc all those string functions, and then any other tools associated that you use to help with your design, even updating the tin design, etc. So the potential there to miss something gets quite large, and then you've got to work out what you missed. With the design chain, however, because it's all there, I can simply come and hit the run button, and it will go through the process of updating all those features. You can see it flashing away there. In case you didn't see it flashing, I'll zoom in a little bit closer and I'll run it again. You can see the alignments flash and then all the strings flash. I get the recalc of the tin panels to let me know that they've happened. I get an OK in the chain. Also, if I go and check the output window, you'll see that it has completed the design chain. The other great thing about a design chain is if one of your alignments does error, it stops. You simply come to the output window, it'll tell you which alignment it stopped on. You can then go and see what the problem was and fix it up. Some other things I have in this design chain, you'll see the traffic islands down further, but before I did that, I updated a tin surface for them to drape onto, and the strings update. I've also got a recalc of the design tin in here. Before I did that, I've used the utilities change, and I've combined all the design models into one model. This way, if I was to add more design functions, I don't have to go and update the tin function to include those extra models. They'll automatically be included. So you can do things like that in your chains as well. I'm not going to go into too much more detail with the design chain. Again, if you go to the webinar section of the 12D model website, there was a training webinar done on chains, and you can see that in more detail there as well. But as you can see, very quick to update your design. Everything's shifted over. Now I'm not taking any land out of this property, and the design is fully up to date, ready to keep going. It's even updated my design tin. One other thing with your design chains, just make sure you're out of all your editors before you do run them. So you or your staff may be using none or maybe just a few of those tools. To learn more, we do recommend attending one of our design features training courses in your area. You'll learn a lot more about these features and more, including using layers, using the snippets that come with the 12D library, using the new MTF boxing and snippet boxing with tri-meshes. So hopefully that's given you a different perspective on how you can be doing your design work. Thanks, Lisa. Back to you.
Thanks, Tim. I think we've just got time for a question or two. Jack in Brisbane said, you mentioned selecting items or strings with the middle mouse button. Can you show that again?
Yep, certainly. I'll just go back to my 12D model. I'll just open up the MTF editor again. And I'll use that string selector to demonstrate it. So your middle mouse button in 12D, when you're in fields like selecting strings or selecting a model, for example, you can use your middle mouse button as same as. So it's great if you can't type like me, or you can't remember the name of your string that you want to modify. It's much easier to go and pick it. So simply put your cursor in the field there, middle mouse button in there, and then go and pick the string that you wish to modify. It will just fill it all out for you.
Thanks for that. And Liz in Sydney would like you to show again how you clicked to open the MTF editor.
Yeah, sure. So opening the MTF editors, a lot of people might do it through the menu, which is Design, MTF, Edit. But this way you have to remember what you called your MTFs, and you also have to dig down through the menu. I find it much easier to edit MTFs by selection, and that's using this Recalc panel here. On this panel we have the Edit Data button, which you can just pick and then select any string or section related to the MTF you wish to edit, and then middle mouse button to accept, and it opens up the MTF editor for you. Much easier and faster to do it by selection.
Thank you, Tim. I'll just read out one more. Ben in Melbourne would like to know why you're using element method instead of IP method for the super alignments.
Yep. So, yeah, okay, using our IP method is a simplistic way to design, but it's very restrictive in terms of what you can do with your design. Also, in terms of editability, using elements is much faster. For example, if I open up this alignment again, and it's a pretty simple alignment, if you were to use IP method, you would have an IP at the start and an IP at the end. So to change the offset of those, you would have to relocate both those IPs. In an element design, you've seen simply it was just a case of changing the offset number and hitting set. It's much faster to update, and you do get a lot more power with elements. You also get the use of computators with element method. You can't do that with IP design. So whilst there's probably a little bit more at the front end of elements to learn, I suggest you start using them or have a look at them, because I guarantee you'll never design a road with IP method again once you start using elements.
Great, thanks Tim. And thanks everyone for your questions. Sorry to those we couldn't get to live. We'll answer you individually afterwards as we're just running out of time now. The recording of this webinar will be available in coming days through our website and our YouTube channel. Our final Industry Solutions webinar for 2016 will be a year in review on the 15th of December. We've got plenty more great webinar topics ready for 2017 though, so we'll update the website with those and keep you posted through email and social media. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.